Hello, beautiful people. Future me. Welcome to another programming workout of mine. So let's just start with it, shall we? So the typing in the interval of 5 minutes and then 25 minutes, and today it will be SQL. Well, not today. This exercise. I was doing two exercises today already. Okay. Cool. — 6%. I'll just keep going, shall we? We are out of the time. Okay, so let's continue in this guy. So reset that, start this, go. So we are creating table users, cats, commands. Okay, so this one will select name. Name, and it will take ID gets comments. Okay, so name is in the cats, and that will be, what's this, fluff. And text. It's that. Okay, that's a good one. What do we have here? Users comments, then we are inserting something, and then the test. Okay, so users ID name, text node, comments, user ID is 40, comment text. Now we are insert and the user's name. Amir and comments user ID, so that is the one. Okay, and users name, that will be Amir, and text we have, and that is SS fluff needs that, like so, and close it. The code problem. Use a giant to get a list of usernames for every command in the system. Make it a live join so that it also includes users who have never written a command. They'll have a no command. Select only name and command text. Okay, so we will select and text and name. And we are joining what? We have users and comments. What do we want? We want everything, so that will be a live join on. Okay, and those names are unique. Okay, so we have a name and context. Yeah, that looks good. Name, then we will say from users left join comments. Is it comments? Yeah, it is. On users.id IDs usually, yeah, okay. Yay! On versus where? Sort of already. Find the pairs of cats of owners where the person name is the same as the cat name. All the examples in this lesson will use this database, but it will always be empty at the beginning of each example. So your people, cats. Cats are linked to have a foreign key in the people table. Names not know. Wilford has a cat named Wilford. And Cindy has no cat. Okay, that's okay. First, we'll do the query in a straightforward way using both on and where. We use on to match people and cats using owner ID foreign key. We use the where to select only the person cat pairs where the owner name is the same as the cat's name. Note the S column aliases. So we have a person name and cat name, okay. That one, so we will have the one that is a Wilford. And that is the person name. Oh, this is not inside of, I think it should be. So, person, Wilford, and then we will have a cat. Oh, it's person name. So name, cat name, and that is Wilford as well. Like so. If we like, we can move the people. Goes cat's name checked into on, eliminating the where. Okay, do you put a comma between the conditions or what do you do? And you do and, so it will be cat name will be Wilford and person name will be Wilford. The cat's name isn't a foreign key to the person's name, but that's okay. We can still compare those columns in the on. Databases don't limit what we put in a on, just like they don't limit what we put in where. If the column exists, the database will let us join on them. We can also convert the entire on into where. Okay, so that is a person. Oh. Person name Wilford. Cat name will be Wilford as well. And we have, what do we do? Everything is same, and we don't have on, everything is in where. And I have person name, so I will do person name. Conceptually, this version is computing every combination of person and cat, then filtering that giant list. For each person, each cat produce new temporary row that contains this person columns with with this cat's columns. For each of those combination, every person with every cat, if the cat's owner ID matches the person ID and the cat's name matches the person name, include this combination of person and cat in the final results. As always, the mental model above is correct, but the database will intelligently optimize the query to make it faster. If we have 10,000 people and 10,000 cats, the database will not produce a temporary list of 100,000 rows. All three of the queries above are truly equivalent and on mixed with where and an on only and where only. So why bother with on at all? Why not always use where? That's a good question. Let's analyze that question along three dimensions: performance, correctness, and clarity for human readers. First, performance. Modern databases are very good at optimizing on and where. You are unlikely to encounter a performance problem that's fixed by converting an on to where or vice versa. So performance isn't a reason to choose one or the other. Second, correctness. For hidden joins, the common type of simple joins that we are using here on and where are interchangeable. Your query will never be wrong if you convert one to the other. However, on and where are not interchangeable for any other type of join. In left, right, and other more rare types that we don't cover in this course, like outer, converting an on to a where can change the results. Okay. Third, clarity for human readers. An on should specify which rows from left table go to which rows from the right table. Here are some examples of good ons. They concern the relationship between two tables joined. Matching the left table foreign key against the column that it references in the right table. Matching email addresses in an invitation sent table against email addresses. Matching email addresses in an invitation sent table against email addresses in our users table to find out what percentage of invited users eventually register, assuming that there is no proper foreign key between the tables. Here are some examples of conditions that are better in where than on. They are not about the two tables relationship. Okay, selecting range of rows, like where created at some dates here. Selecting a specific row, like where user ID equals something or where cat's name equals something. Separating on conditions from where conditions help with both correctness and clarity. It makes mistakes with rare types of joins less likely. Where converting an on to where will give different results. It also gives readers a hint about whether the condition concerns combination of left and right arrows. There's no hard and fast rule about when to use on versus where. The example that we started with lives in a gray area where either choice makes sense. Putting the people.name equal cats.name condition in the on is probably slightly better, but neither is wrong. You'll do fine as long as you ask yourself, is this condition about how the left table relates to the right table, or is it about something else? And we finish. Oh, okay. And I'm off the study material. Okay, so maybe I can check if the Web3 schools have a tutorial on SQL. JavaScript server side. Oh, learn SQL. Cool. How will I do it? SQL standard log. Yeah. Okay, let's go. What is SQL? Structured query language. Lets you access and manipulate databases. Became standard to the American National Standards Institute in 1986 and of the International Organization for Standardization. What can SQL do? Execute queries, can retrieve data, insert records, update records, delete records, create new databases, create new tables, create stored procedures. What's the stored procedure? Can create views in database, set permissions on tables, procedures, and views. Standard, but although SQL is an ANSI ISO standard, there are different versions of the SQL language. However, to be compliant with the ANSI standard, they support at least the major commands such as select, update, delete, insert, where in a similar manner. Most of the SQL database programs also have their own proprietary extensions in addition to the SQL standard. Using SQL and your website. To build a website that shows data from database, you'll need an RDBMS database program, MSXS and stuff like that. To use a server-side scripting language, PHP, ASP. To use SQL to get data you want. To use HTML, CSS to the page. Relational database management system is the basis for SQL and all modern database systems such as MS SQL Server, IBM DB, Oracle, and so on. The data in RDBMS is stored in the database objects called tables. A table is a collection of related data entries, and it consists of columns and rows. Okay, let's have a look. I'll get those things. Okay. Oh, quite big. Okay. Every table is broken up into smaller entities called fields. The fields in the customers table consist of customer ID, customer name, contact name, address, city, postal, and country field. Fields or columns, maybe. Fields, okay. Field is a column in a table that is designed to maintain specific information about every record in the table. A record, also called a row, is each individual entry that exists table. For example, there are 91 records in the above customers table. A record is a horizontal entity in table. A column is a vertical entity in a table that contains all information associated with specific fields in a table. Tables more often contains one or more tables. Each table is defined by name, customers, orders, contains records. This tutorial will be well-known North Wind sample database included in MS Access and MS SQL Server. Below is a selection from the customers table. Sure. The table above contains 5 records, one for each customer, and 7 columns. Most of the actions you need to perform on a database are done with SQL statements. Following SQL statement selects all the records in the customers table. I'll teach you about the different SQL statements. Keep in mind, SQL keywords are not case sensitive. Select and select is the same. We'll write all SQL keywords in uppercase. Semicolon after SQL statement. Some database systems require a semicolon at the end of each SQL statement. Semicolon is the standard way to separate each SQL statement in database systems that allow more than one SQL statement to be executed in the same call to the server. In this tutorial, we will use semicolon at the end of each SQL statement. The most important is select, update, delete, insert into, create database, alter database. Okay, so this is interesting. Maybe columns, create table, alter table. Okay, so now I don't know. Well. Third table, drop table, deletes, create index, create an index, search key, okay, drop index, that's interesting. Okay, I don't know those. The SQL select statement. The select statement is used to select data from a database. Data returned is stored in a result table called the result set. Here the column 1 and column 2 are the field names of the table you want to select data from. If you want to select all fields available in the table, use the following syntax. The star, yeah, that one I know. The name of database, select column example. Customer city from customers that I know. Select that I know. Exercise, sure. Oh, crap, I did not submit the delete it. Open, so Uh, we'll select submit. Submit, correct. Write the statement, select the city column for customers. Okay, select city from customers, correct. What's next? Select different values from the select all the different values from the country column in the customers table. What? Distinct. That's after this one. That's give me 2 hours. Well, never mind. We are 2 minutes over the time limit, which means we are done. Done is better than perfect, and I will see you next time.